Another operation which we can apply to vectors is the power operation. So let's calculate j as x dot to the power of x. Well, let's say z to the power of z. And now let's run that. And now let's compare. We had x, which is 0.5, 2, and minus 1. And we have z, which is 3, 2, and 0. So we can see that the first thing here is 0.5 to the power of 3. This is 0.5 to the power of 3. So the next element, which is 4 here, is obtained as 2, which is a second x element, to the power of 2, which is a second z element. And now 1 is obtained from minus 1 to the power of 0, which is just 1. So what this operation does, it increases x by applying the power of z element-wise. First element of x to the power of first element of z, second element of x to the second power of z, and third element of x to the power of third element of z. Now let's do the same with y, and y to the power of y, let's say, which we will save as k. Run. 0.736, which we got from first element of y to the power of first element of y. Then 0.25 is the second element of y to the power of second element of y, which is minus 2 to the power of minus 2, which is 1 over 4, which is 0.25. And then third element of y to the third element of y to the power of the third element of y, which is 3 to the power of 3, which gives us 27. So we can also apply power element-wise. And in general, we can apply any operation to any two vectors if they have the same name. Let's say the name of this vector is a row vector and the row vector, and the name of this vector is column vector and column vector. So we can apply any operations with dots to column vectors or to row vectors which have the same length. But if we mix row and column vectors, as we saw before, we should get a matrix. Let's do that. L will be x to the power of y. And let's suppress the output from these comments, and we will get the matrix. We got the matrix. Again, we see that we have complex numbers because for some operation of this kind, there's not enough just real numbers. That's why MATLAB uses complex numbers. But the main thing here is that, again, we see that operation on a row vector and a column vector gives us a matrix. These operations we will not consider, and we will always use row vectors with row vectors and column vectors with column vectors.